So for people who are studying their ATPLHs, your helicopter path is always going to start at this vector diagram. Now if you can understand and draw the basic vector diagram, it makes understanding recirc, ground effect, retreating blade stall so much easier because you can manipulate the diagram and talk your way through it. If you're studying for your fixed wing, by having a look, your basic vector diagram is the same as your propeller theory. It's just turned 90 degrees on its head. And once I realised that, it just clicked in my head for propeller theory. But we are going to start with our fixed wing aircraft. So we know our weight is acting downwards, and to oppose weight, we need lift. What's driving us through the air is our thrust, and opposing our thrust is our drag. Now that is just your single aerofoil as it moves through. However, because we've got a rotor blades, or 3-4 rotor blades, spinning through that same air repeatedly, we've got this flow going through like this, and then as it's constantly going through, it's inducing a downwards flow of air, and that's what's known as our induced flow, which will be important. So thinking of our rotor blades now, they're spinning round on our basic vector diagram, and we need an axis of rotation. As our blade spins through the air, it's going to give us a plane of rotation. Now we know our lift realistically is acting around about this area here, but for ease of the diagram we slide it up to this position. We see we've got a chord line that's going through our aerofoil, and with our blade spinning we've now got a rotational airflow. That's going to give us a pitch angle. But we mentioned earlier we've got that induced flow as our aerofoils are moving through that air, and that's now going to give us what's known as a relative airflow. From there we've now got an angle of attack. And what's acting 90 degrees to angle of attack is our lift, and 90 degrees to that is our drag. And the resultant vector of our lift and drag gives us a total reaction. From there we can work down, and we see we've now got a rotor drag. Now to oppose that rotor drag, we've got our torque acting in the opposite way. Again, if we go across from our lift, we can see we've now got a total rotor thrust acting on our axis of rotation. And opposing that is our weight. And a few things to note on our diagram: our induced flow is not actually to scale, otherwise it'll be somewhere up here. The induced flow may only be 20 odd knots, but our relative airflow could be up to 430 knots, far faster. And that is our basic vector diagram. If you can draw that and understand it, everything else that follows on from here will be far more easier to understand.